Dear students, Assalamu alaikum. Today we are going to start our part 1 physics lectures, and the article is projectile motion. Projectile motion is a two-dimensional motion under constant acceleration due to the gravity. So this is the definition of projectile motion. In the projectile motion, a particle is thrown upward with an angle of theta along x-axis with some initial velocity vi. So there will be two components of the velocity, one along the x-axis and one will be along the y-axis. So the velocity component along the x-axis is vix, that will be equals to vi cos of theta. Okay, and the component along the y-axis will be viy, that is equal to vi sine of theta. But after some time t, the velocity component along the x-axis or the horizontal component of the velocity remains equal to the initial component of the velocity along x-axis. So the final velocity is equal to the initial velocity along x-axis, and v of x or vfx is equal to vix, and this is equal to vi cos of theta. So the horizontal component of the velocity remains constant during the motion of the projectile. But for y-axis, the component of velocity becomes vfy is equal to vi sin theta minus gt. So the component of the velocity along y-axis gradually decreases with time t. So if we want to calculate the velocity or the magnitude of the velocity at any instant of time, so this will be equals to v is equal to vfx square plus vfy square whole under root, because vfx and vfy are the perpendicular component of the velocity. So we can find the magnitude of the resultant at any instant of time. So that velocity will be equals to vfx square plus vfy square. You can find the velocity v by putting the values of vfx and vfy here. And also the direction of the velocity at any time t can be calculated by the expression tan of phi is equal to vfy over vfx. So phi can be calculated by tangent inverse vfy over vfx. So this was about the velocity of projectile along x-axis and y-axis after time t or at any instant of time t. So next is the height of the projectile. So if we see a projectile, when we throw into the air at some angle theta with x-axis, so it attains a maximum vertical distance at this point, and this is the maximum height. Okay, the vertical distance at any instant of time t covered by projectile is known as the height of the projectile. Say at this time its height is this one, at this time its height is this one, and this is the maximum height. So if we see at the maximum height, the velocity component along y-axis becomes 0, because the body is not moving upward. After this point, the projectile starts moving downward. So at this point, at the maximum height, the vertical component of the velocity becomes 0. So height of the projectile. In order to determine the maximum height of the projectile, we use the equation of motion 2as is equal to vf square minus vi square, and we know that the body is moving upward, so acceleration will be equals to a is equal to minus g, and the initial vertical component of the velocity was vi sin theta, and the final velocity component around y-axis at maximum height becomes 0. So putting all these values in the equation, we get the relation of the maximum height, that is equal to vi square sine square theta over 2g. So this is the expression for the maximum height of the projectile. So next is time of light. Time of light are the time taken by the body to cover the distance from the place of its projection to the place where it hits the ground is known as the time of flight. So by definition it means when we throw the projectile from its initial position, the time taken by the projectile from the projection at the initial point to the point where it hits the ground is known as the time of flight. So during this time, the projectile covers the maximum horizontal distance, or the time for which the projectile remains within the air, or the time taken by the projectile from its initial position to the final position of the landing is known as time of flight. So if we see the vertical distance at both these points, initial point or the point of projection and the point of landing is 0. So the time taken by the projectile from initial point where its vertical distance is 0 to again the point where its vertical distance becomes 0 will be equal to the time of flight. So for this we see that the vertical distance becomes 0 in this time t, because the body goes up and comes back to the same level, the snow covering vertical distance. So we use the equation S is equal to VIT plus half GT square, because the acceleration due to gravity will be negative. We are throwing the body upward, so the negative sign is here, and the component of the velocity will be along y-axis, so that's what is equal to Vi sine theta, and this t is the time of flight. After solving this equation, we get the relation of the time of flight, and that t is equal to 2 Vi sine theta over g. So this is the time of flight for the projectile when it remains in the air, or the time taken from the point of projection and the point of the landing. So next is range of the projectile. Projectile covers two distances, one along the y-axis or the vertical distance, and other is along the horizontal axis. So the maximum horizontal distance covered by the projectile is known as the range of the projectile. Like a cricketer hits the ball, so it also covers two distances. One is the vertical and one is along the horizontal along the ground. So for the time of flight can be defined as the time taken by the body to cover the distance from place of projection, range of the projectile. Maximum distance which a projectile covers in the horizontal direction is called the range of the projectile. So this is the definition of the range of projectile. How can we find now the range of the projectile? So because it is the horizontal distance, so we will take the horizontal component of the velocity and the time of flight for which the body remains within the air, or the time taken by the body to cover this range, this maximum distance along the horizontal. So the relation is R will be equals to Vix multiplied by t, where t is the time of flight and Vix is the x component or the horizontal component of the velocity. So putting the values of these, R is equal to Vi cos theta, this is the x component of the velocity, and time of flight we know is equal to 2 Vi sin theta over g. So the expression becomes Vi square of g into 2 sin theta cos theta, and also we know that 2 sin theta cos theta is equal to sin 2 theta. By mathematical or trigonometric relation we know that 2 sin theta cos theta is equal to sin 2 theta. So thus the range of the projectile can be written as Vi square over g into sin 2 theta. So from this, if we want maximum range, or at the angle for which the maximum range can be obtained, we should have the value of sin 2 theta maximum. The maximum value of sin 2 theta is 1. So 2 theta Sin 2 theta is equal to 1 and 2 theta will become equals to sin inverse of 1, that is equal to 90, and the theta becomes 45. So at the angle of projection of 45 degree, the horizontal or the range of the projectile is maximum. Like if a cricketer or the footballer wants that he should cover the maximum horizontal distance, he should hit the ball at the angle of 45 degrees. So this was all about projectile motion. If you have any query or any question about this article, you can freely ask. Thank you very much.